Alright, so welcome. This is going to be a challenge section for chapter 7. And we're going to divide polynomials. We've added, subtracted, and multiplied polynomials up to this point, but we have not divided. I'm going to teach you a certain type of dividing where we are simplifying by factoring, and then we are going to divide out what becomes 0 and then simplify the expression that way. So let's just go through a quick review on what makes a fraction equal to 1. So anything over itself, like 3 over 3, if you divide that, it's going to give you 1, right? Anything over itself is 1. So it doesn't matter if it's a number over a number, or if it's a letter over a letter, anything over itself divides out to be 1. Okay? Now, for example, for this third example, I just have a term, which is 3x, divided by the same exact term, 3x. Okay? If you wanted to break it up, 3 divided by 3 cancels out. X divided by x cancels out. Same thing, it's equal to 1. Right? Anything over itself is equal to 1. Okay, good. So now, let's go through a couple of examples where you don't have exactly something over itself, okay, but you can simplify it using the division of 1 of any number over itself. So if I have 3x, okay, if you look at your numbers, okay, if you look at your numbers, I have a 3 there, and then in front of that 3, I have an invisible 1. Now, is that the same number over the same number? No. So that's just going to simplify 2. 3 over 3 is just 3. Okay, then I have x over x. X over x divides out to be 1. So essentially, I really just have 3 times 1, which is just 3. So if I have 3x over 1x, the x's cancel out, and I'm just left with 3. Okay, let's go through a little bit a different example, because now we have a number over the numerator and the denominator. And let's just deal with the numbers first. So 4 over 2. Now think division. 4 divided by 2 is 2. Good. Okay. Now, if you remember back to your exponent rules, you can think of it two ways. You have division of two terms. Division of two terms means that you're going to subtract the exponent. So if I have 2 minus 1, you're going to have x to the first power. Okay? And that's my answer. Now, if you broke that up into what actually x squared is, you could break that up into 4x times x times x. And that's over 2x. So we broke down 4 divided by 2, we know is 2. Now, if you see now that we broke it up into the factor of 4x squared, you could cancel out those x's, okay? And then you're just left with 1x. So that's why I have 2x. Awesome. So now I'm going to do it the shortcut way, and then I will show it the long way for number 3 as well. So for number 3, let's deal with the numbers first. So I have 5 and I have 10. So if you were to simplify that expression of 5 over 10, that simplifies to 1/2. Okay? Then I have x to the 4th divided by x to the 1st. So if I have division, I subtract the exponents. So now I'm going to have x to the 3rd power. So if I have x to the 3rd power, I'm going to leave it like that. So I have 1 times x to the 3rd power over 2. Now, if I have an expanded form of what that actually means, I could have 5 times x. 5 times x times x times x all over 10 times x. Oh, I'm missing an x. Okay, good. So now I could cancel out what's the same. So if I have x over x, that cancels out, and I'm left with x times x times x, which is x to the third power. And then I have 5 divided by 10 simplifies to 1/2. Okay, so it's the same thing. I just did it 2 different ways. You could choose which way you'd like. Okay, now we're going to go through a little bit more advanced example, and this is kind of really what we're going to do. So now, even though I don't have one term over another term, I have a quantity. So if you have the same parentheses, same exact parentheses, over the same exact parentheses, you still have something divided by itself, and that's going to give you 1. Okay? So for this first example, for the fourth example, I have x plus 1. I'm dividing that by x plus 1. So really, I have the same thing over itself, or divided by itself, and that's going to cancel out, and you're just going to be left with 2x. That's my answer. Okay, now, that's if you have your factors pulled out for you already. You have a parentheses over a parentheses, you could just cancel out, then you're going to be left with whatever you're simplified with. Okay, now, looking at example 5, I don't have any parentheses that I could cancel out right now. So when you want to go ahead and divide polynomials or divide any type of expressions, okay, you're always going to want to try to factor. So when I factor, I'm going to try to factor out a GCF. Always try to factor out a GCF first, and then you're going to go ahead and cancel out. Those are the examples I'm going to give you for this section. So always try to factor out a GCF. So looking at 3x minus 3, I could factor out a 3. So if I factor out a 3, I'm going to be left with 3 times x minus 1. All right, if I took out a 3, 3 times x is 3x, 3 times negative 1 is negative 3. It's going to be all over x minus 1. So essentially, I have x minus, my mistake. I have x minus 1 over x minus 1. And that's going to cancel out. I'm going to be left with 3. Okay, and that's my answer. Okay, lastly, I have an example of 2x squared plus 6x. So I'm going to try to factor out something first. So in this example, I could factor out a 2. Let me write it down here. I'm going to run out of room. I'm going to factor out a 2x. So if I factor out a 2x, what times 2x is 2x squared? I have an x. What times 2x is 6x, and that's plus 3. Okay, so that was the factored out numerator. Those are equivalent, right? All I did was move there, and I'm down there. Okay, that's just the factored form. Okay, now I'm just going to rewrite the bottom, or the denominator. It's going to be over x plus 3. Okay, x plus 3. Now you can see that you have, let me get rid of that. So now that you could see you have x plus 3 over x plus 3, and you're going to be able to cancel those out, and you're just left with 2x. Okay, so those are a couple examples of dividing polynomials by factoring. Okay, so always try to factor out a GCF. Those are the type of examples I gave you for this section. You could always try to factor all different ways. If you need to use the X method for general trinomial where a equals 1, or the X box method where the a value is greater than 1, you have to do so as well. But your ultimate goal is to find expressions or quantities that can cancel out. Then you're going to be left with your simplified answer. All right, good luck with the practice.